I'm Francesco De Marchi from Nextworks, and this POC deals with analytics attacks to the NWDAF, and it specifically deals with the managing of the threats of tampered data supplied to the NWDAF. So during normal operation, the NWDAF ingests data from a set of security functions from their network events, and then uses those informations to compute analytics and provide them to the interested party, in this case, the telemetry. And over time, what happens is that the model is retrained to keep the prediction accurate and up to date. So that once a threat actor tries to do an attack, in this case, we are considering the abnormal behavior metric, and specifically the suspicion of DDoS attack exception. So that once a threat actor shows up and the data is delivered to the NWDAF, the MTLF can compute the metric and drive the necessary remediation. However, if either if the network function or in general the connection to the NWDAF is not reliable and is intercepted or compromised, the data supplied to the NWDAF can be tampered with. If this data does not trigger the model immediately, over time it can accumulate, and through a series of retraining runs, these poison data can skew the model so that the predictions are not accurate anymore. So that when a threat actor shows up and attacks the network, the NWDAF does not provide an accurate metric that can drive remediations. Our solution to this is a closed loop approach that attaches both remediation interfaces to both the NWDAF and a closed loop that acts on those interfaces. So that when a poison data stream is injected through tampered data, the data is sent to this closed loop. And once a poison data is sent, it is detected, and mitigations are applied to the NWDAF, such as posing the poison data stream, and if the data is not sufficient anymore to reliably compute the metric, also pose the subscription. So this is the full composed security functions. We have 4 dots in total: an open telemetry exporter to talk to the MARE telemetry, a security enhanced NWDAF, which exposes remediation endpoint, zero-touch security framework, which is basically a closed loop, which also integrates the 4th dot, which is a model for tampering detection. In practice, this works by using the monitoring platform component of the NWDAF, which gathers the data from the network functions, which is then collected by the monitoring stage, which is then taken by the analysis stage, which uses the ML model to get analytics that then drive the decision stage, which chooses a specific remediation playbook that follows the Cacao standard, which is then executed by the execution stage within a dedicated Cacao playbook interpreter service, which uses OpenC2 format commands to enact those remediations on the security enhanced NWDAF. So in practice, this is deployed through Kubernetes. Each dot is a Helm chart, which lets them compose together. Okay. So how does this first stage look? So at the beginning, the OpenTelemetry agent requests the subscriptions, specifically the exception, suspicion of DDoS attack exception for the abnormal behavior metric, which then triggers the data collection from the monitoring platform, which collects the event through a set of telegraph collectors, which then forward the data to the analytics function, which provides the actual analytic telemetry, which is requested by the agent, which is then forwarded to the MARE telemetry so that other components can act on these threats or on the telemetry in general. In practice, the closed loop works in this way. So the monitoring stage collects the data from the time series database into which the telegraph pods push the data. these data is then forwarded to the analysis stage, which calls the AI ML model, which through a prediction endpoint give analytics regarding the nature of the provided data. This data is then given from the analysis to the decision stage. In the decision stage, this data is then mapped, these alerts are then mapped to a specific playbook, which is then fed to the execution stage. And the execution stage basically calls the Cacao playbook interpreter service, which executes the playbook in full through an interpreter and uses an OpenC2 actuator, which reads OpenC2 formatted commands to call the specific remediation endpoints on the NWDAF. So once the OpenC2 commands are dispatched and called to the NWDAF endpoints, the NWDAF detects the poisoned data stream and proceeds to remove it from the monitoring platform set of active data streams. And if the set of data streams remaining are not enough to provision a proper analytics, a proper reliable analytic, then the subscription is paused and the OpenTelemetry agent is notified so that the telemetry can be notified as well. The interested party can be notified as well. So in practice, by continuously running this security function, we can detect in almost real time the potential threats to the NWDAF, and so to in general all of the components that rely on the telemetry provided by the NWDAF. In the second iteration, we plan in extending the set of functionalities to also monitor model drift detection and also validate data sets used to train the ML models, the MTLF ML models, before training. This concludes the presentation, and if there are any questions, please ask, and thank you for your attention.